Hello class, it's just me, Mr. Wee. I'm going to continue with some more calculus today. Today we're going to, or let's see, for this lesson, we're going to actually learn how to use limits, the limit of h as h goes to 0 for word problems to try to find slopes of, like at certain points at word problems. So let's check this out. This is actually number 30. Let me see if I have this marked down in your book. I guess I don't have the number down, but I think you'll recognize it. So this isn't actually a topic name. This is just the name of this specific type or this problem, not type of problem, but just this problem in general. So you're given an equation, an EQ for free fall. Free fall. Equation for free fall is S is equal to 1.86 t squared. So the variable is t, and the function is what's called s, sort of like y is equal to 1.86 x squared. Okay. And then also t is basically in seconds, units of seconds. Okay. And then you're also given this: a rock is dropped from 200 meters. Sorry about that. Please find the speed of the rock. At t is equal to 1 second. I believe it's written with a little bit more detail, a tad bit more detail than what I just gave you. Let's take a look at what this says. The equation for free fall is s is equal to 1.86 t squared. We know that t is in seconds, that's time. So this is a function of time. Okay. What I didn't tell you is that this is the speed as well. S is short for, let's see, it's not s. I'm sorry. This is what is it? This is actually in meters. So this is this function should tell you the position. So this tells you. So this is s of t basically. So this is a function of time. Okay, should give you something that is in meters. Okay, so if you plug in what time, so if you plugged in t is equal to 1 second right now into this equation, so if I plugged in at 1 second, this would tell you like how high. Let's see. So let's just say we're on a cliff right now, right? And we have a person here. Okay, we have a person here, and he drops a rock. So as that time is equal to 1 second, let's say that the person had the rock here and it's now here. Okay, that's the rock. So what is the s equal to? So right here. So at time of 1 second, right? This is time of 1 second. So this is, I know it looks hard to say, but it says t is equal to 1 second. What would be the s be? The position, right? But it's not asking for that. It's actually asking for the speed of the rock. Okay, at that one particular t is equal to 1 second. Okay, so you're going to look at the change. We're going to look at the change of its position right now. Okay, at that particular 1 second. So I'm not actually asking for s, but I'm actually asking for the speed, which is the change of s over time. Okay, so what this looks like is like this. We're going to take we're going to take the limit as h approaches 0. Okay, and then we're going to take the s of 1 plus h minus s of 1 over h. If you think about it, and if you remember, the origin of h is 1 plus h minus 1. Okay, this is the change in s, or the change in the distance, the meters, okay, over the change in time. So if you can think about it here, this is the meters over time. This is the slope at this particular 1 second, okay? And if you look at it here, it's meters over time. That gives me a speed, if you think about it. Limit of h approaches 0. So let that sink in, try to kind of figure out what I just said there, okay? So now what this is going to look like is it's going to be 1.861 plus h squared. So if you remember, the original equation is s is equal to 1.86 t squared, okay? And here, t is technically 1 plus h minus 1.861 squared, or h. And if you do out some more math here, if you expand this out, so the rest isn't too bad at this point. This is basically 1 plus h squared. So what this actually means is 1 plus h times 1 plus h. And if you remember FOIL or the distributive property, we're going to have to do that for this guy. This one's not too bad. It's just 1.86 times 1 over h. So the math's never bad. It's just setting it up is really tricky. 1.86 times 1 squared. This is plus 1h plus 1h. And this is h squared minus 1.86. Okay. So this is very tedious over h. So this is the limit again. It helps to do every step. You don't have to do every step, but let me kind of back this up and let you see like every step so far so you can kind of follow along. So this is 1.86 times 1 plus 2h plus h squared minus 1.86. Let's distribute this 1.86 to every other number that's in this parentheses that we just formed. Okay, and then I should get limit as h approaches 0, 1.86 plus, what is it? I think it's 3.72h plus 1.86h squared minus 1.86 over h. This will cancel out, and then we're left with this statement here. Let's continue on the next page. On the back, save some paper here. So now I think we have the limit as h approaches 0 of 3.72h plus h squared over h. And if you notice, let's factor out an h out of both of these terms at the top. So you have the limit as h approaches 0 of h times 3.72 plus h over h. These cancel out. And now I'm left with a statement where I can actually plug in the h plus 0, or h of 0, because remember, if I tried putting that in earlier, that would give me a statement that doesn't exist, or it gives me infinity. Now if I take this, 3.72 plus h, and h is equal to 0, my final answer is going to be 3.72, and if you remember, it was meters over seconds. So I got to find the speed at which this guy, so basically in my drawing here, at t equals 1, I didn't find out what s is equal to. Okay, I didn't find out exactly. Actually, look, maybe that would help. The rock is dropped from 200 meters. Okay, the rock is 200 meters, but I'm looking for the speed of the rock. So this doesn't actually really tell me anything about 200 meters. So that might kind of be like a. So if we were the rock is dropped from 200 meters, this actually doesn't help us. This is actually meant to throw you off. So we're not looking at how high. So s I know is kind of off-putting because it looks like s would be speed. That's what we would think. But s is actually a function that just gives us meters. It just gives us where the rock is. Is it at 200? Is it 190? Is it 170? What we're looking for is the speed. And the speed at this exact instance, t equals 1, if we plug it in, is a slope. It'd be the meters divided by the time, okay? And basically the difference in time would be 1 plus h, between 1 plus h seconds and 1 second, okay? And that would give me a gap of h in which we're making that gap go to 0, a very small gap, like a very, very small difference. So that way we can find an exact slope at just one particular point at t equals 1. Okay, so that's why that 1 plus h and that h is approaching 0. So we're really finding the slope at just 1 second. Okay, so again, the slope is meters divided by time, or meters divided by seconds, actually, so to be a little bit more exact. Okay, all right, guys, hopefully that helps you out conceptually about what's going on. If you need more help, I'll be here to help you during tutoring time. Guys, have a great day. I'm going to stop the video. Bye.